Alright, today we're continuing our section on triangle congruence proofs. Today we're going to cover the angle-side-angle theorem, angle-angle-side theorem, and the hypotenuse-leg theorem. Firstly, the angle-side-angle theorem, also known as ASA, says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. What this basically means, if so, you have two angles congruent and the side between those two angles are congruent, then the triangles are congruent. This example would be if angle A is congruent to angle D, segment AB is congruent to segment DE, and angle B is congruent to angle E, then triangle ABC is congruent to triangle DEF. Let's look at example 1 here, where we are given segment SQ bisects angle RQT and angle RST. Prove that triangle QRS is congruent to triangle QTS. Alright, so again, we're going to first mark our picture. If we have segment SQ bisecting angle RQT, then these two angles must be congruent. And also, if SQ bisects angle RST, then these two angles must be congruent. Now, these two triangles also share a common side, which is segment QS, so QS must be congruent to itself. Now, whenever we look at this, we have two angles congruent with the side between them congruent to each other. So these triangles are congruent by angle side angle. Again, we know what our goal is going to be. We're going to circle angle side angle and move on to the actual proof. Again, the left side is the statements, the right side is the reasons. Statement number 1 says SQ bisects angle RQT and angle RST. The reason why we know this is that it was given to us. Statement number 2 then says angle RQS is congruent to angle TQS. Reason why we know that is because it was bisected, so we're going to use definition of bisect. Statement number 3 says angle RSQ is congruent to angle TSQ. Again, we know that that was bisected, so again, it is definition of bisect. Statement number 4 says segment QS is congruent to segment QS. Those are the same line, so it is reflexive property. Now, statements 2, 3, and 4, segment 2 is an angle, statement 3 is an angle, and statement 4 is the side, satisfy as all three parts of our angle side angle theorem. So we can then conclude that triangle QRS is congruent to triangle QTS by angle side angle. Now let's look at the next theorem, which is the angle-angle side theorem, also known as AAS. If two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. Again, that should say congruent, not included. Alright, what this basically means is we have one angle congruent to another angle on the other triangle next to an angle that is congruent to the other angle, and then the following side afterwards would be congruent to the following side of the other triangle. With this example, if angle A is congruent to angle D, angle B is congruent to angle E, and segment BC is congruent to segment EF, then triangle ABC is congruent to triangle DEF. Let's look at an example. Example 4 tells us that segment YZ bisects angle WX or WYX And we also are given that angle YWZ is congruent to angle YXZ. We're trying to prove that triangle WYZ is congruent to triangle XYZ. So again, we're going to first mark our picture. If we know that segment YZ bisects angle WYX, then we have these two angles that must be congruent. The second part says that we have angle YWZ congruent to angle YXZ. So that means that these angles must be congruent. Alright, and then the third part that we get here is we have segment YZ being the same segment on both triangles, so it has to be congruent. When we look at this, we have an angle next to an angle next to a side. So the triangles are congruent by angle, angle, side, which is going to be what we're going to use for our proof. Alright, we're going to circle that and then come back to using that later on. Again, we got this completely blank, so we're starting off from scratch. I always would start off with the very first statement that we were given. Segment YZ bisects angle WYX. The reason again is we were given it. Now that does not give me any of the things that I need for the angle angle side theorem, so I'm going to continue off on that actual notion to give me my first actual angle and say that angle WYZ is congruent to angle XYZ. Again, we mark that on our picture first because we knew it bisected, and that is by definition of bisect. So now we use that first given statement to give us one of the letters that we need from this for this proof. So we can now move to the second given statement, which is angle YWZ is congruent to angle YXZ. Again, the reason for that is it was given. So now we have the first two angles, and now we just need this side given to us. So segment YZ is congruent to segment YZ because it's the same line, so we use reflexive property. So 2 satisfies an angle, 3 satisfies an angle, 4 satisfies the side. So now we can say triangle WYZ is congruent to triangle XYZ by angle, angle, side. Now let's look at another example. Number 5 says, given angle ABC is congruent to angle CED, and segment AB is parallel to segment CE, and C is the midpoint of segment AD, prove that triangle ABC is congruent to triangle CED. So let's first mark off the angles they give us at first. So here's angle ABC congruent to angle CED. The next thing they gave us is that segment AB is parallel to segment CE. Right? And then the third thing was that C is the midpoint of AD. So now we know that AC must be the same as CD based off of the fact that C is in the middle of that. So right now we're given an angle and a side. We don't have any other information based off of what we have marked. However, we're going to use the fact that AB is parallel to CD to note that segment or angle A and angle ECD would be corresponding parts, with the transversal being line AD. Okay? That would end up making A and angle ECD both in the same spot, which means that they have to be congruent to each other. So now looking at the figure, we have E and B congruent, A and ECD congruent, and then segment AC and segment CD congruent. So it's in the order of angle, angle, side. Alright, we know where we're going to go for this. We'll circle that. And now we're going to start with our statements. So again, we start off with what we were given first. Angle ABC is congruent to angle CED. Reason for it? Given. Then our second one is that segment, oh right, uh, alright, sorry, I had to correct this. It should be segment AB is parallel to segment CE. Reason why we know that is it was given. Alright, what that ends up telling me, that does not give me the angles or anything yet, so I need to end up figuring out how to get to an angle from that, and we end up concluding that angle BAC is congruent to angle ECD because they are corresponding angles. So that gives me my second angle for the angle side. Now I just need to get the side. So we're going to use the next given part, which is C as a midpoint of segment AD. Reason for it, it was given. That concludes now that AC is congruent to CD by definition of midpoint. That gives us the third part for our triangle congruence theorem, which then is triangle ABC is congruent to triangle CED by angle side. Now, the last one of these triangle congruence theorems that we're going to talk about is the hypotenuse leg theorem, which states if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Now, this will only work in right triangles, hint why it's the hypotenuse on it. You only have a hypotenuse on a right triangle. Right. Another way to look at this is the angle side that actually works. The only time that the angle side theorem would work is if it is a right triangle. So if segment BC is congruent to segment EF, which is the hypotenuse, and segment AB is congruent to segment DE, then we can say that triangle ABC is congruent to triangle DEF. And again, this only works in right triangles. So looking at example 1 here, we're given that triangle LMN or LMP and triangle MNP are right triangles, and that we have segment ML is congruent to segment MN. Alright, we're going to mark our pictures. We got this other right angle here that we were given. We're also told that ML is congruent to MN, so these two are congruent. The other thing that we have to know is congruent is MP on both of them because they're the same line. So that gives us our hypotenuse congruent and one of the legs congruent of these, so we know it's going to be hypotenuse leg. Circle that, and then we're going to work through our proof. We know that the triangles are right triangles because they were given to us. We then know that segment ML is congruent to segment MN because it was given to us. We then know that segment MP is congruent to segment MP because of the reflexive property, because they're the same line. And we lastly then have now the leg and the hypotenuse, and we know that it's right triangle, so we can say that these triangles are congruent by hypotenuse leg.